Welcome to Graphs and Waveforms. Okay, so what is a graph? In general, we've got two axes. We've got an x-axis and a y-axis. We can think of x-axis, generally speaking, as like maybe a date or a time or a frequency, and the y-axis is some kind of count or multiple or amplitude or some kind of gain. Now the other point we need to define is the exact center of the graph. Between the x and y coordinates, we've got what is called the origin. So basically we've got two types of waveforms. We've got what is a repetitive or periodic waveform. These are waveforms that are repeating and are identical after each cycle. And an aperiodic waveform, which is a waveform that does not have successive cycles or is not identical. And you can think of it as the A indicates kind of without a period, aperiodic. And so you can also think of A as in arrhythmia, so no rhythm or irregular heartbeat, apathy, no interest or concern. Astable multivibrator, no stable state. And at any single point on the waveform is represented by the instantaneous value. So you can think of an instantaneous value as a specific point on the graph. Okay, so here are some examples of typical periodic or repetitive waveforms. We've got the sinusoidal, square or rectangular. We've got ramps, exponential, triangle, sawtooth, and spike waveforms. So here's a typical aperiodic waveform. You can see it's got the spike going down. It looks a lot like the spike waveform on the other previous slide, but the difference here is it's probably like a one-time event. It happened and then it's gone. Other aperiodic waveforms you could think of, it would be like noise or something that's just not repeating. So here is a display method that we are used to in electronics, the oscilloscope, where the y-axis is amplitude in volts and the x-axis is in time. Here is a display of a spectrum analyzer. It's essentially our Bode plot graphically represented where y-axis is gain in dB generally, and the x-axis is frequency domain.